In this video, I will tell you about the annotative property of AutoCAD objects. So up to this point, you must have seen that there are lots of AutoCAD objects or lot of AutoCAD entities that use annotative property. For example, we have text that can be used with annotative property. We have hatches, dimensions, and other objects like blocks which can be used with the annotative feature. To understand this annotative feature, I will explain it first with a very simple example. Now here in this drawing, the second one, we have these two simple rectangles and we have two simple hatches here. In both of these cases, the hatch has been made with a 1:1 scale. Now as you can see here, we have 1:1 scale applied on the current drawing area and they are equally spaced hatches. Now when I move my cursor to this white hatch, it's behaving in a normal way. On the tooltip you won't see any new icon, but when I move my cursor to this hatch pattern, a new icon is visible which represents annotative property. So right now the green hatch has annotative property, whereas the white hatch has normal properties. Here we have multiple icons of annotative property, and that indicates we have multiple scales added to this annotative object. Now I'll make this clear using the layout view of this drawing. So currently we have it in 1:1 scale. Let's move to the layout. Now when I move to the layout, here I've got three different viewports. In the first case, we have the first viewport here with a scale of 1:1. As you can see here, it has been represented with the help of field. So this viewport has a scale of 1:1. When I double click inside, you will be able to see here that the scale is 1:1. Now in this scale, look at the hatch pattern. Now the spacing of hatches is equal in both of these cases. Now look at this hatch pattern. In this case, the scale is 1:2. Now in this case, as I am decreasing the scale, the gap of this normal hatch has also decreased. It has reduced to half of its original gap as it was in this 1:1 scale. So obviously this will follow properly here. The scale of this viewport will reduce the scale of hatch pattern in normal hatch, but look at the annotative hatch. In this case, the gap of this hatch pattern is still maintained, and when you compare it with the original hatch pattern of 1:1, the same gap is maintained, although in this case the number of hatch lines are reduced in order to accommodate the same hatch gap. Now if you look at the third case here the scale is 1:4. So obviously in this case, when you look at the normal hatch pattern, the scale has been reduced to 4 times of its original value, and the gap has also been reduced to 4 times of its original value. But in this case, again, the same scale has been maintained as it was in the case of 1:1 hatch pattern. So that's the annotative property. When you apply annotative property to an object, you can keep consistent size throughout different scales. Now I'll explain it using another example. In this case, we have the simple drawing, and right now this is the floor plan, and as you can see that we have this floor plan, so the size of this object is quite large. It's in the scale of 30 to 35 feet along the length and 25 to 30 feet along the width. Now this scale is the actual scale of the drawing, and obviously when you plot this drawing on a sheet of paper, you need to reduce this scale, because obviously we cannot make a sheet of paper of a length in the scale of 30 or 40 feet. So that's obviously not practical. So in order to do that, what we do actually is we create layouts as we did here, and the size of this layout is A3. So we create layouts with a standard paper size, now in this case A3, and then we reduce the scale of original object. Now when the scale is reduced, all the objects fit properly, and also the annotations can be added directly. Now in this case, here you can clearly see that the scale has been reduced to 1:50. That means that when this drawing, which is on the paper, is increased to 50 times, it will be equal to the size of actual object. Now in this case also, when you look at the dimensions, you will notice that they have a very particular size here, and this size has been chosen depending upon the size of paper. Right now I have selected 1/4 of an inch as the size of this dimension, and that's a size which is quite visible on this kind of sheet of paper. Now in this case, when you go to the model space, you'll see that the same dimension size has been applied, which is 1/4 of an inch, but it is obviously not visible because we need to zoom to this dimension in order to see this. So that's the scale, 1/4 of an inch, that's the size here, and obviously this is not visible in this case. But even after reducing the scale, we are able to properly see this dimension because the annotative property has been applied to this. To make it even more clear, I will show you this another example. Now in this case, the scale has been increased to 1:20 and further to 1:10. Now we have three different scales. In this case, the scale was 1:50. In this case, 1:20 and 1:10. Now obviously with the change of scale, the scale of this drawing changed. In this case, we are zooming into this kid's bedroom, and as we zoomed into this area, all of these text blocks and the remaining objects increase in size. But when you look at the dimension, their size still remained constant. In this case, when you go to this drawing, you'll see this is the size which is maintained for this scale, and here also when we zoomed it even further, the scale is still maintained. That's only because the dimensions are annotative. So whenever you apply annotative property to any of the objects, it will always remain consistent in size throughout the different scales.